Today we're going to go over distributive property, which is similar to an idea we did talk about yesterday. Distributive property is when you have numbers within a set of brackets that you cannot simplify any farther, and the entire set of brackets are supposed to be multiplied by a term or a number on the outside. So anytime we end up with a situation where a number or a variable is beside a set of brackets, they're telling us they want us to use multiplication. And with that multiplication, they want us to take the value on the outside and multiply it by both of the terms on the inside of the bracket. Let me go through the question, and then if you still have another, we'll go. Okay? So, what that means is we'll underline the first set in blue. I have to multiply x times x. Now, if you guys remember from our exponent rules, what would x times x be? Not 2x. How did you get x squared? Okay, so technically there's a power of 1 for both of these. And when we're multiplying bases that are the same, we add the exponents. So because this is 1 plus 1 in the exponents, we have x to the power of 2. Okay. If you're unsure how to set this up, we'll break this down really into a second step. So the first thing we needed to do is set up x multiplied by x. Okay. And the second thing we need to do is then multiply x by -3. So this will be added to x times -3. Okay, I know I have a whole bunch of lines here, but that is just to simplify what we are doing here. We're essentially multiplying this term by both of them. So I've set them up beside each other. We just talked about how x times x will equal x squared. And what will x times -3 equal? Sure. -3x. Many of you are going to be confused at this step here. You're thinking, where did this positive sign go? But remember, let's say we did have that positive sign there, and then we had -3x. When we have a positive symbol beside a negative symbol, what does it become? It becomes a negative. So the positive disappears, and we're just left with x squared minus 3x. I'll rewrite it all in black, but that's essentially our final answer here. So our second example here, we have p multiplied by all the terms in the brackets. Now we should check the bracket, according to BEDMAS, to see if we can simplify. Are any of these like terms? No. So I cannot simplify this bracket any farther, which leads me to the next step of using distributive property. I'll multiply p times p squared, p times -2p, and p times 1. When we do that, p, and I guess we'll write them all out, first step in green, p times p squared will be our first one, which will then be added to p, we'll do that second one in red, I guess, p times -2p, added to, let's see if we have room, p times +1 or 1. Whenever we have a sign that is a subtraction in front of a number, we associate it with that value, and you associate it to be a negative value. So this says p squared combined with -2p. We say p squared minus 2p, but it means the same thing when we're combining. Okay? Combination is to add or subtract values. So I just lined them all up here. What is p times p squared going to be? John? That's right. We have p cubed. Good. What will p times -2p be? -2p to the power of 2 or squared. And finally, what will p times 1 be? 1p, or just the value of p. Right? We don't have to write that 1 in there. And this is our final answer. We cannot simplify this set of brackets any farther. So we're left with p cubed minus 2p plus p. So with this same idea, we know this is distributive property now. I need to multiply the 3 by all 3 of the terms. So what would 3 times x squared be? 3x squared. That's it. Okay, I'm not going to put any addition or any subtraction signs. The next step. What would 3 times positive 2x be? Positive or negative? Positive. So we put plus 6x. Okay? Maybe this is simpler for you. What will 3 times negative 9 be? Negative 27. So we put subtract 27. And that's it. We're at our final answer. We don't need to use that middle step there. That's it.
That's easier.